In this lecture, we're going to learn about the STD forward list container. And this is a container that is designed to provide very fast insertions and removals anywhere in the container, including the middle of the container, which is really problematic because we have to move elements around. The STD forward list container is able to do that because of how it stores data internally. So internally, each element is going to have a pointer to the next element. For example, if we have in this data here, the first element is going to have a pointer to the second element. We will have a situation like this. The 20 element will have a pointer to the 30 element, and this will go until we hit the end. And if we want to traverse our container, we can go through these pointers. So we can go through the pointer in the first element and get access to the second element. We can go through the pointer stored in the 20 element here and get access to the 30 element. This is how these things work. And the STD forward list container doesn't have to use memory locality to go from one element to another because elements can be really stored non-contiguously in memory. Here is a simple example of something we might have. So our first element, which is this 10 here, is living at this memory address. 20 is living at another random address. 30 is living at another random address. And because STD forward list uses internal pointers that it uses to point to the next element, the first element, which is our 10 here, might have a pointer to the 20 element and set up something like this. We have a pointer which is going to point to the location when we have the 20. From the 20 element, we will have a pointer that points to the element that contains 30. So we might have something like this. Let's do this. We're going to go from 20 to the 30 element. So we might have something like this. From 30 to 40, we might have something like this. Let's set up a pointer which goes to the memory location where we have 40. You can do something like this. And from 40 to 40, we will have a pointer that goes to 50. And from 50, we will have a pointer that goes to 60. We may set up something like this. And when we want to traverse our container, we will do something like this. We will go from the first element and look at the next pointer. We're going to go to 20. We're going to go this way. And from here, we're going to go from 20 to 30. And we're going to be following our pointer here. So we're going to go this way and find our next element. From 30 to 40, we will follow our pointer and go to 40. From 40 to 50, we will follow our pointer and go from 40 to 50. And we will do this until we hit the end of our container. And everything is going to fall in place. You're going to see that this is going to work, but we don't require memory locality for this to work because of the pointers we have going from one element to another. One thing that is going to be a consequence of this is that we are only going to support forward iterators with STD forward list. We can move from one element to another going forward by using our pointers, but we really have no way to go backwards because we have no pointers going from the last element to the first element. So STD forward list is only going to support forward iterators. And if you try to use reverse iterators on this container, that's not going to work. You are going to get a compiler error. Another thing I want you to see is that if we happen to add a new element in our collection, that's going to be really easy because that's going to be a matter of rewiring the pointers. Let's try and set up our succession again. So we can go from 10 to 20, just like this. I think we can do this. From 20 to 30, that's going to be something like this. We're going to go from 20 to 30. And if we want, for example, to insert an element between 10 and 20, we will set that element up somewhere. So this is going to be, for example, 15. Let's put in a 15. And if we want to insert this element, all we have to do is to break the connection from 10 to 20. So we will break this connection here. And what we will do is make the connection from 10 go to 15. And then from 15, we will go to 20 and do something like this. We can do something like this. And our connection is going to be rewired. And notice that all we had to do was change the pointers and change where they are pointing. And our new thing is going to be set up. This is really confusing because the arrow from 15 is going through our X sign here. I think we might do better. So we're going to do something like this. And we will go to 20. And now if we try to go through our list, we will go from 10 to 15 on top here, and then we will go from 15 to 20, just like this. And if we want, we can keep going. You can see that inserting things in the middle is really a matter of breaking up connections and setting up new connections. And that's going to be really fast because it's a matter of cross-assigning a few pointers, and our list will be wired however we want. Okay, so here are a few facts about our std forward list container. It is implemented as a single linked list in memory, so we will have a bunch of pointers between elements. And that's going to be something like this. Each node is going to have a pointer to the next element. You already know this. And elements may be stored non-contiguously in memory. And this is a defining feature of std forward list. And because elements may be stored non-contiguously in memory, we can't move from one element to another by pointer arithmetic-like operations. Because if you increment the pointer, it's going to go somewhere where you don't have the data in your list. So you should know this. To go from one element to another, we will have to use the pointers stored in our items, and that's going to work really well like we have here. Poor memory locality is going to make things a little harder if you are traversing your list. And another consequence of poor memory locality is that we can't use random access iterators. We have to somehow traverse the list to find the element that we want, and that's going to be a little bit costly. Another thing worth noting is that we don't have reverse iterators in forward lists. The reason is that we only have pointers that allow us to go in a forward fashion from one element to another. And to have reverse iterators, we would somehow need to set up pointers that go backwards in our list, and std forward list doesn't support this. I am going to show you another container that supports this, but for now, we are interested in forward list, and that's what we're going to look at here. To get access to a given element, you have to do some kind of linear search and go from one element to another, checking to see if it contains the value that you are interested in. And once you are at the correct location, you can do your operations. You can retrieve the element, you can insert new elements, which is going to be very fast. But I don't really recommend using std forward list in production code because of the lack of the random access iterator, which would make things a bit easy to get and use elements. So I would recommend to use std vector, which is going to make things a bit easy, and it is not going to be performing significantly worse in terms of inserting and removing things in the middle, which is a really shining feature of std forward list. Now, we have seen a few things about std forward list, and I would recommend coming back to CPP reference and really reading all you can about it. We have a bunch of member functions here. For example, we have those for element access. We have those for the capacity. We have those we can use to modify our collection. You can read all you can about these members, but we are still going to look at a few examples to really drive this home in our slides here. So to use std forward list, you need to include that in your program, and you do that just like you see here. And after we have this included, we can create our containers. You say std forward list, you specify the type, you give it a variable name, and you put in data. You see that these things are really usable in the same way. And after we do that, we can use our print collection function to print the data, and we can access the front element. Notice that we don't have the at method like we did before. We don't have the array index operator. So one easy way to get access to elements, for example, you can get the front element and get a copy of that and print that out as you see here. It is also possible to clear, so we can use the clear method to empty our collection. But after we empty it, it is also possible to insert new elements. For example, we can reassign data to our container using the syntax here. And it is possible to use the insert after method to insert after a given iterator. To be able to insert an element in the first slot, we can use the before begin iterator, which is going to give us an iterator before the first element in our collection, and then we can use the insert after method to insert an element in the first slot of our collection. This is going to work really well. If this is confusing, please bear with me. I am going to show you this in a minute in Visual Studio Code. Another thing we can do is in place after, and this is going to do what we expect. It is going to in place an element after a given iterator. We can also erase after a given iterator. And the way we do this here, this is something I don't think I have talked about. We can use the stdFind method to find an element in our collection. And once we have an iterator to that element, we can use the methods we have in our std_for_list container to do things. For example, we can erase, we can do all kinds of crazy things. In this case, we are interested in erasing after a given iterator. Once we find an element, we're going to get an iterator to it in our variable here. And we can check and see if this is different from the end iterator. If it is, we would have found our element. If it is equal to the end iterator, we will know that we haven't found our element. So from this, you may note that the stdFind method is going to search for the element in your collection. If it finds it, it's going to return an iterator to that element. If it doesn't find it, it is going to return the end iterator. This is how these things work. So once we have an iterator to the element, for example, we can erase after it, and this is going to give us what we expect. The element is going to go away. It is also possible to pop from the front, so this is going to take an element out of our container. We can resize our container just like we did for the std_deck container. We can resize to 10 here, for example, and this is going to make our container have 10 elements. We can resize down to 3, and if we happen to resize up again to 10, we are not going to get the elements we lost back. You should really know this. So after you resize up again, the other elements are just going to be 0 initialized. It is possible to swap things up just like we did for the previous lecture. So we're going to call the swap method and elements are going to be swapped up. It is also possible to merge two forward lists into one. And the way we do that, we call the merge method like we do here. And this is going to make numbers1 contain all the elements from the two lists. We can call the splice after method. And what this method allows us to do is to take a range of elements from one container and store them in another container. So for example, here we can grab a range of elements from numbers2. For example, we can grab these numbers and put them back in numbers1, starting at a given index, for example. We can do something like this. It is also possible to remove elements, and if we say numbers remove here, this is going to remove one instance of the one value, but it is also possible to specify a callback that the collection is going to use to decide what should be removed from our container. And we do that by passing a predicate to the removeIf method. And the predicate is really like a callback that the compiler is going to use to remove stuff. So here we want to remove any element that is greater than 10. So we're going to loop through our collection, finding elements. And if the element happens to be greater than 10, it is going to be removed. And after we print our collection here, you're going to see that anything that is greater than 10 has been removed. So we're going to remove the 100 here, and we're going to remove the 11 here, and we're going to remove the 12, and all these guys are going to go away. We're going to see this when we hit Visual Studio Code in a minute. It is possible to also reverse a container, and this is going to reverse the order of elements. We can remove duplicates that are contiguous in a collection. For example, here, we can remove this duplicate and we can remove this duplicate, but this is not going to remove duplicates that are not contiguous. So for example, the one here and the one here are going to be left in the collection. This is how the unique method works on our std_list container. It is also possible to sort elements in a given order. For example, from the smallest to the largest, we can do something like this. And these are things you can do with your std_list, but I still recommend using the reference here to have an exhaustive list of things you can do. For example, we have a bunch of iterators we can use. We have non-constant iterators and we have constant iterators. We have before begin iterator, which is going to give us a slot in front of the container so that we can add elements in the first slot. This is what we can do. We have a bunch of modifiers method, and we had a chance to look at this in the slides. Now I am going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is forward list. We are going to grab our template files pretty quick and put them in place. And let's open this up in Visual Studio Code by dragging and dropping here. This will give us our main CPP file that we can play with. Let's close the sidebar here. We don't need it again. And we will include our forward list header. I think this is going to do. I am going to put in our print collection method, which is everything we have seen before. We are going to create our collection here. So let's do that. We're going to say std forward list. We're going to put in data just like you see here, and we can call our print collection method to print the data to see that the data is actually in. But one thing we want to see is how to use the front method to get access to the first element in the collection if you want to do that. And this is how you do this. So let's pass this through our compiler. We're going to use GCC for that. The build is good, so we can bring up a terminal window. And if we clear and run Rooster, we're going to see that we have our data in from 100 all the way to this 5. We have the data in, and the front element is the 100 we have in. If we go back to the documentation, we're going to see that we don't have much flexibility in how we can access the data in the list. And this is by design, because to find an element, you somehow have to navigate in the list using the internal pointers we have from one element to another. And we don't have the facilities we had in std vector, for example, by using the random access iterators, because we don't have them here. So we have the front method we can use. Where did I find it? Do we even have that here? Let's see if I can find the front method. So this is the only element access method we have. For iterators, we have a few iterators we can use for our std forward list container. For example, we have a begin iterator, we have an end iterator. We even have the before begin iterator, which is going to give us a slot in front of the first element. So what we're going to be able to achieve with this is get a slot in front of the first element in our collection, and we can use this with insert after methods to insert things in the first slot of the container. This is how we can use the before begin iterator, and we will have a chance to play with this in this lecture here. We also have a bunch of modifier functions we can use. So for example, we can clear to remove all the elements from the collection. Here we're going to print our collection with elements, and then we're going to clear. And after that, you're going to see that the collection is going to become empty. We can do something like this. Let's pass this through our compiler. The build is going to be good, so we can clear and run Rooster. This is going to give us our collection, and then we're going to clear it and see that it is going to become empty. We can also use the insert after method to add elements after a given iterator. Here we're going to use our before begin iterator, which is going to give us a slot in front of the first element again. So after we call the before begin iterator, we're going to get an iterator pointing before the first element in the collection. So if we insert after this iterator, we will be inserting in front of the first element, and the 333 element here is going to show up in front of this 11. So we're going to print our collection before we insert, and after this, we're going to see that 333 is going to become our first element. Let's pass this through our compiler and make sure this is actually the case. The build is good, so we can clear and run Rooster. You're going to see that after we insert 333 is our first element. We can also in place after a given element, and this is going to build the element in place for our custom types. So if, for example, this is a custom type, our constructor would be called and in place in the first slot in this collection here. And we're going to see that 444 is going to become our first element. We can build our program and see if this actually works. The build is good, so let's clear and run Rooster. You're going to see that 444 is going to become our first element. We can also use the erase after method to erase after a given iterator. And here we're going to use the std find method, which is really an algorithm that is useful with the std forward list, in that it is going to try and find an element in the collection. To use it, you give it a range. So we give it the beginning and the end of our container, and it is going to try and find 13 in our container. If it finds it, it is going to return an iterator to this element. If it doesn't find it, it is going to return the end iterator. We can check against here. So we can do a test to see if what we return from this function is not the end iterator. If it's not the end iterator, we will know that we have found our element. If it is the end iterator, we will know that we haven't found our element, and we will say that right here. So let's try and run our program and see if we found the 13 to see if this actually works. The build is good, so we can clear and run rooster. We're going to see that 13 is inside and we have found it here. Now we can remove things after the 13 here. Let's view our output again. We're going to see that we have a 14 here that we can remove using the remove after method. So let's go down and do that. We're going to erase after our iterator, and the current iterator is pointing to 13. And if we erase after this iterator, we're going to be erasing the 14 that we have in our collection here. We can see that right here. So we're going to remove it. Let's pass this through our compiler. The build is going to be good. As you see right here, we can clear and run rooster. And after we remove the element, you're going to see that 14 is going to go away as a result of this erase after call. Hopefully you understand this. It is also possible to pop the front element and remove that from our collection. We're going to print the data we have in. We're going to pop the front element and then we're going to print again and see what happens. We can pass this through our compiler. The build is going to be good, so let's clear and run rooster. We're going to see that we're going to pop the 444. This is how this method is going to work. We can also use the resize method, just like we saw in the last lecture, to resize up or down. Here we're going to resize to have 10 elements. We're going to resize down to have 3 elements, and we will resize up again. And one thing worth noting here is that if you resize up after resizing down, you're not going to have the elements you lost when you resize down right here. So you should really know this. Let's pass this through our compiler and see this in action. The build is going to be good, so we can clear and run rooster. Down here, we're going to see that we have our collection. We are going to resize it up to have 10 elements. So that's going to give us the data we have here. And then we're going to resize down to have 3 elements. You're going to see that 13 and 15 are going to be lost. But if we resize up again to 10 right here, you're going to see that we're not going to get the data we lost back. We are just going to zero initialize new memory locations that we get in our collection. This is how these things work. We can also swap things up using the swap method if that's what we need in our application. And here we have a simple example. We're going to have 2 forward lists. One is going to be other numbers, the other is going to be numbers, and then we're going to swap them up and see that they exchange data, just like we saw in the last lecture. So this is nothing new now. So let's pass this through our compiler. The build is good, so we can clear and run rooster. We're going to see that numbers contains 333, 11, 12, and all kinds of crazy things here. And other numbers is going to contain the data we have right here. And if we swap them up, we're going to see that numbers is going to contain 200, 400, and 600. And other numbers is going to have the data we had in numbers previously. And we have swapped these things up successfully. We have a bunch of other operations we can do. For example, we can merge lists. So here we want to merge numbers 1 and numbers 2, and we're going to have all the data in these 2 collections in the collection where we do the merging. So if we go down here and merge numbers 2 into numbers 1, we're going to see that numbers 1 is going to contain all the data. Let's try and pass this through our compiler and see the behavior. The build is good, so we can clear and run rooster. And we're going to see that if we merge the data we have in numbers 2 into numbers 1, the data is going to go for good. The data is going to move from the list that we use as a parameter, and you need to be aware of this. So you see numbers 2 is going to become empty after the operation to merge from numbers 2 into numbers 1. This is how this method works. We also have a splice after method, which can be really confusing, especially for beginners. Here we're going to put data in numbers 1 and in numbers 2. And we have the ability to move data from a collection and put that in another collection and have only part of the data moved into the other collection. So for example, we can do something like this and take a range of data in numbers 2. For example, we can grab these elements and move them in numbers 1, starting at a given iterator. For example, you could put them after the 5 element here. So let's try and do something like this. We're going to put a statement to do this. And the splice after method is going to take the location in the destination container where we want to add elements. We want to use the before begin iterator. So we want to insert before the first element in number 1. We're going to specify our source list. So we're going to be stealing data from numbers 2, and we will say the range. The range is going to be from the beginning all the way to the end. So we are going to steal everything. And you're going to see that the data is going to move from numbers 2. It's going to go into numbers 1. And we're going to see that the data is going to go in front of this one here. At least, that's what I think. Let's pass this through our compiler to see if I am right. The build is good, so let's clear and run Rooster. And we're going to see that the data is going to move from numbers 2. You see that numbers 2 now contains one element. And let's look at the starting point we specified. So the data is going to be moved from the beginning iterator, but the element at the beginning iterator is not going to be moved. You see that the 9 here was not moved. If we want to move everything, we can say before begin here. I think that's going to do. And if we build and run again, we can clear and run Rooster. And we're going to see that everything now is going to move from numbers 2, and we're going to put the data in numbers 1 before the first element because that's what we specified here. You can really set up these iterators however you want. So this is how the splice after method works. If you want more information, you can go in the documentation, find it out and see how it works. You're going to find a lot of documentation on here. So you can read all these things if you want. It is also possible to remove elements from our collection. For example, if we go down here, we're going to try out the remove method, and we're going to specify which element we want to be removed from our collection here. And some of you must be asking, are we going to remove this little guy in the first position, or are we going to remove this one here? Well, let's find out. We're going to pass this through our compiler. And the build is good as you see here. So let's clear and run Rooster. And we're going to print our collection with this one, and we're going to see that the one that was removed is the first one. And if you want to know how this remove method works, you can go to the documentation and learn more details about this. Another thing I want you to know is that we can also set up a callback that is going to be reused by our collection to decide which elements to be removed. So let's specify a remove predicate. And the predicate is really a callback that you can pass to your remove method to decide which things should be removed. We're going to call the remove if method. This is another version of the remove method we have. And you see that it's going to be removed if this predicate is satisfied. This is one way to look at this. So what we want to do is remove anything that is greater than 10. And the collection is basically going to loop through all the elements. It's going to run this predicate on each element and ask it, are you greater than 10? If the element is greater than 10, the predicate is going to return true and the element is going to be removed. If the element is not greater than 10, the predicate is going to remove false and the element is not going to be removed. This is how these things are going to work. Let's pass this through our compiler and see how this works. The build is good as you see here, so we can clear and run Rooster. And we're going to see that our remove with predicate is going to remove anything that is greater than 10. The 100 here is going to go away, the 11 here is going to go away, and the 12 here is going to go away because they are succeeding on this predicate here. The predicate is basically returning true and telling the collection to remove them. And if you look down here, they have disappeared from our collection. This is how the remove if method works if you want to use it for your collection. It is also possible to reverse the data in your collection by using the reverse method, just like we see here. So we're going to print our data. So we're going to print our data before we reverse, and we're going to print the data again after our reverse and see how this works. Let's pass this through our compiler. The build is good, so we can clear and run Rooster. And we're going to see that the data has basically been reversed. So 12 is coming first and we are going backwards in our collection. We can do something like this if it makes sense for whatever problem we are trying to solve with C++. We can also use the unique method to remove contiguous duplicates from our container. So for example, if we try to make our container unique, that's going to remove 100 here, and it is going to remove 11 here because these are contiguous duplicates, but the duplicates that are not contiguous are not going to be removed. So the one here and the one at the back are going to be left in our collection. Let's pass this through our compiler to see what is really happening here. The build is good, so we can clear and run Rooster. We're going to see that the 100 here is gone and the other 11 here is gone, but the duplicates that are not contiguous are left in our container. This is how our unique method works. You should know this. Another thing we can do, which is pretty cool, is to sort our collection. So we can print our collection here and sort it again, and we're going to see that everything is going to be sorted from smallest to largest. I think this is the default we're going to get, so let's build. The build is good. We can clear and run Rooster. We're going to see that after we sort everything, we're going to be going from smaller element to larger element. So we're going to see that now we're going to have all our duplicates contiguous, and once we have this, we can then call our unique method to remove them. So we can go down and do our thing here, and if we call the unique method again, now all the duplicates are going to be removed because they should be contiguous as a result of our sort call here. I hope this is not confusing to you. Let's pass this through our compiler. The build is good, so we can clear and run Rooster, and we're going to see that all our duplicates are gone now and everything is sorted out nicely. This is really all I had to share in this lecture, showing you all about the std4 the list container. Don't forget that internally everything is going to be stored non-contiguously, and the way this container is going to work is through a bunch of pointers that go from one element to another in a forward way in our list. If you want to learn more about this container, please come back to the documentation. You're going to have more things than I even had a chance to talk about in this lecture. For now, we're going to stop here in this one. In the next one, I am going to tell you about the std list container. Go ahead and finish up here and meet me there.